In this example, I'd like to do a couple evaluations with a piecewise function. Let's say we'd like to calculate f at 4 for the following piecewise function. Well, the first thing we need to do is look at this value of x and determine which one of these intervals 4 lies on. Notice that 4 is bigger than or equal to 3. So 4 lies on the following interval, which means we should use this piece of our piecewise function to do the evaluation. F at 4 is going to be 5 minus 4, which is 1. Next, if x is equal to negative 3, that means that x must lie on this interval. Negative 3 is less than negative 1, so we're going to use this piece here to do our evaluation. In this case, we're going to get 3 minus negative 3 squared. This is equal to 3 minus 9, which is negative 6. Finally, for f at 2, 2 lies on this interval. 2 is in between negative 1 and 3, so we're going to use this piece here to do our evaluation. We get 2 times 2, which is 4. If we were interested, we could give a rough sketch of this piecewise function that we used in our example. Let's take a look at our first piece, which is 3 minus x squared when x is less than negative 1. If we want to plot this portion of our piecewise function, we're going to take the endpoint, which is negative 1, substitute it into our formula. When we substitute in negative 1, we'll get 3 minus 1, which is 2, and that's going to give us an open circle at negative 1, positive 2. I'm just going to note that here. And then we go back to our formula. What is this if it wasn't inside of our piecewise function? Well, this would be a parabola that faces downwards, and its vertex would be at 0, 3. So that parabola might look like this. But remember our restriction here. We only want to look at this parabola when x is less than negative 1. So all of this portion of the parabola here I don't really care about. I'm only interested in this portion over here. And then we repeat this procedure for our other formulas. So for our second piece we have 2x when x is between negative 1 and 3. When we substitute negative 1 in, we get negative 2, so that gives us a closed circle here at negative 1, negative 2. And if we substitute 3 into the formula, we are going to get 2 times 3, which is 6. And that's going to give us a point at 3 and 6, an open circle up here. And connecting these two together, we get our line 2x when x is between negative 1 and 3. And then finally we can move on to our last portion, which is 5 minus x when x is greater than or equal to 3. If we sub in our endpoint of 3, we'll get 5 minus 3, which is 2. So that's going to give us an ordered pair at 3, 2. This is going to be a closed circle. And recall that this is a line that slopes down and to the right with a y-intercept of 5. And take only the portion that is greater than or equal to 3.